Write down question. E and F are respectively the midpoints of the non-parallel sides. E and F are respectively the midpoints of the non-parallel sides AD and BC of a trapezium ABCD, full stop. I repeat, E and F are respectively the midpoints of the non-parallel sides AD and BC of a trapezium ABCD, full stop. Prove that EF is parallel to AB. EF is parallel to AB and EF is equal to half of bracket AB plus CD. EF is equal to half within brackets AB plus CD. This is a question from NCERT exemplar. This question is from NCERT exemplar. Okay, so write down. See here. Huh. Yes. E and F, I'm repeating the question. E and F are respectively the midpoints of the non-parallel sides AD and BC of a trapezium ABCD, full stop. Prove that EF is parallel to AB and EF is equal to 1 by 2 within brackets AB plus CD. You see here, this is the question here. The question says that this is a trapezium here, and name of the trapezium is given as ABCD. AB, this is C and this is D. ABCD is this, and here you have these are the midpoints right over here. E is this, E is this point, and F is this point. Okay, the question says E and F, these are the E and F are the points, midpoints of this non-parallel side. These are parallel sides of the trapezium, and these are non-parallel sides. This is the midpoint here, this is the midpoint here, right? This is the midpoint here, and this is the midpoint here. Then the question says that you have to prove that EF is parallel to AB. This line is parallel to, you join EF. EF is parallel to AB and EF is half of AB also. EF is parallel to AB and EF is equal to AB by 2. This you have to prove here. Okay, two things you have to prove. EF is parallel to AB and EF is equal to, first thing you have to prove here, to prove EF is parallel to AB and EF is equal to half of AB plus CD. So these two things you have to prove. EF is parallel to AB and EF is equal to half within brackets AB plus CD. Okay. Now write down solution for this. Given Given ABCD is a trapezium, given ABCD is a trapezium, given ABCD is a trapezium, comma, given ABCD is a trapezium, to comma, E and F are the midpoints of AD and BC. E and F are the midpoints of AD and BC. AB is parallel to DC. AB is parallel to DC. Full stop. To prove that, to prove that to prove that EF is parallel to AB and EF is equal to half bracket AB plus CD. Construction. Construction. Join BE. Construction join BE and extend it to meet CD produced at O. CD produced at O. Join BE and extend to meet CD produced at O. I repeat, join BE and extend to meet CD produced at Q. You can take Q at Q. Okay. Now see the proof. See the proof. In triangle AEB and DEQ, in triangle AEB and triangle DEQ. Can you see now? A E B and D E Q. You see this and this are vertically opposite angles. These two are vertically opposite angle. This is the midpoint, so these two are equal, and this are alternate angles. Check vertically opposite angles, alternate angles, and this side is equal to this side. Yes. So both the triangles will be congruent. Both these triangles will be congruent, right? Okay. So first point you write down in both these triangles, this triangle and this triangle. First of all, write down angle BAE, angle BAE is equal to which angle? BAE is equal to angle QDE, because these two are parallel lines, and when two parallel lines are intersected by a transversal, then these alternate angles are equal. So you can write here alternate interior angles. Alternate interior angles are equal. Okay. Second point. Second point. AE is equal to DE. Why? Because very good. E is the midpoint. Of AB. Got it? Third point you see, third point you see, angle AEB is equal to which angle? DEQ, है ना? DEQ. Why? Which type of angle? Vertically opposite angle. Correct. VOA, vertically opposite angle, are equal. So here you see this angle is equal to this angle, this side is equal to this side, and this angle is equal to this angle. So both triangles are congruent. Huh? Triangle AEB is congruent to triangle. Which triangle? DEQ. Condition is side angle. Huh? One angle was there, one side is there, then again angle, angle, side, angle. Okay. Now, if both these triangles are congruent by this condition, so what you will have here, that AB is equal to what? AB will be equal to which side? DQ. Good. What's the reason for this? CPCT. Correct. CPCT. Again, you see, AE is equal to what? AE is equal to ED. है ना? A is equal to ED. This is already given because they were the midpoint. है ना? And you again see B is equal to what? B is equal to B is equal to EQ, correct. What is the reason for this? Okay. So now what is there? E is the midpoint of BQ. Na? Therefore, E is also midpoint of, huh? Got it? Got my point? Huh? So in triangle now you see in triangle BQC, in triangle BQC, in triangle BQC, BQC triangle. Can you see this triangle BQC? Ah. Q is there, Q is there, C is there. है ना? So here you see BQC the triangle. This side and this side both are equal. This side and this side both are equal. है ना? This side and this side both are equal. This side and this side both are equal. So here you see this line. You can apply here midpoint theorem. If you apply midpoint theorem, what you will get? Line through the midpoint of one side of a triangle. Line joining the midpoints of two sides of a triangle. This is the midpoint here, and this is the midpoint here. So line joining the midpoint of two sides of a triangle is always parallel to the third side. This means this should be parallel to this, and this should be half of this. Got it? Got my point? So write down in triangle BQC. Write down in triangle BQC, comma, in triangle BQC, comma, E and F are the midpoints of E and F are the midpoints of BQ and BC respectively. E and F are the midpoints of BQ and BC respectively. Therefore, by midpoint theorem, Therefore, by midpoint theorem, we have EF is parallel to QC and EF is equal to half of QC. Is it okay? The reason you can write here by midpoint theorem. This is by midpoint. Okay. Now again you see EF is equal to what? Half of QC. And what is QC? Q is this, C is this. That is QD plus DC. है ना? EF is equal to half of QC, and what is QC? You see QC. Can you see na? QC is equal to what? QD plus huh? DC na? QD plus D. And what is QD? Just now you have calculated, found out. What is the value of QD? QD is equal to AB. Very good. So that is equal to huh? Half of QD plus AB. Na? Half. Sorry, wait. Half of AB plus that is equal to half of A. QD is equal to AB. So AB plus DC. Right? Hence true. Okay. Clear? Done na? All of you have done? Right on next question. AD is the median of triangle ABC. AD is the median of triangle ABC, full stop. E is the midpoint of AD. E is the midpoint of AD, full stop. I repeat, AD is the median of triangle ABC, comma. E is the midpoint of AD, full stop. E is the midpoint of AD, full stop. BE produced to meet AC at F. BE produced meets AC at F. Show that AF is equal to AF is equal to 1 upon 3 AC. Show that AF is equal to 1 upon 3 AC. Okay. Now let's see what does the question say. Okay. Is it visible now? Now the question says that there's a triangle, that there is a triangle. You can take this as a triangle here. This is a triangle. Name of the triangle is ABC, and this is the median here. This is D. D. Median means the midpoint of the side joined with opposite vertex. This is the median here, and then it says E is the midpoint of the median AD. E is the midpoint of the median AD. This is the midpoint of median AD, and this is extended here. It meets here at F. Okay, meets at F. Then you have to show that AF is equal to. You have to show that AF is equal to one third of AC. EF is equal to AF is equal to one third of AC. This means this is equal to 1 upon third of AC. This you have to prove. The question is clear? Write down solution for this. Draw construction. Rest I think given to prove. You can write yourself. Write down construction. DG is parallel to BF. Draw DG parallel to BF. This is D, and you draw DG which is parallel to BF. This draw DG which is parallel to this line BF. This is D, this is G. So draw DG which is parallel to BF. This is F. So draw DG parallel to BF. Got it now? Huh? Now you see here D is the midpoint, and this line is drawn parallel to this. These two are parallel. So here line through the midpoint of one side of a triangle parallel to the second side bisects the third side. This is called converse of midpoint theorem. Okay? Hmm? So write down D is the midpoint of BC. D is the midpoint of BC. Why? Why? Yes, because yes, AD is the median. Second thing you see, DG is parallel to BF. DG is parallel to BF. By construction, you have drawn this as a construction part. Okay, this is by construction. And then you see that G is the midpoint of FC. G is midpoint FC. Why? Very good. By converse of midpoint theorem. By converse of midpoint theorem. Now you see that CG is equal to what? CG is equal to GF. Why? Because you see here, yes, CG DG is equal to just a minute. CG is equal to GF. CG is equal to this GF. C is this, G is this, CG is equal to GF. Because this was the midpoint here. This is the midpoint, and this line is drawn parallel here. So line through the you see this triangle here. Line through the midpoint of one side of a triangle parallel to the second side bisects the third side. So these two are equal. This is okay now? So F is the midpoint of F is the midpoint of AG, correct? F is the midpoint of AG. Huh? AF is equal to what? AF is equal to GF. GF, isn't it? And GF is equal to what? GF is equal to CG, isn't it? So if you take all these three, so you will get what? AF is equal to GF is equal to CG. All three are equal, right? Till here it's okay. F is how the midpoint of AG. You see, this was the midpoint here. This was the midpoint here, and this line is parallel to this by construction. The line through the midpoint of one side of a triangle parallel to the second side bisects the third side. So these two are equal. And here in this triangle, you see, this is the midpoint here. This is parallel to this line through the midpoint of one side of a triangle parallel to second side bisects the third side. These two are equal. Is it okay? Huh. So these three are equal. This point is clear now. Huh. So if all these three are equal, that means what? Again, you have what? Again, you have that AC is equal to what? AF plus FG plus GC na? And all three are equal. So that is equal to this is also AF, this is also AF. So you can write this equals to what? 3 times AF? AC. So if you divide by 3, so you will get what? AF is equal to one third of AC. Hence proved. Any doubts you have now? If you have, you can ask.